Good day, doctor. My name is PAVITHIRAN. I'm here to present our control system engineering project. So our second report is cruise control system. Cruise control is a clever system that regulates the engine to keep the car driving at a constant speed automatically. We can on cruise control by manual, then we can lift the accelerator to make way for the cruise control to take over. We can off the cruise control by manual or pressing brake, and eventually the cruise control turns off. Our objective is to evaluate the performance of different classical control scheme P, PI, PID of a cruise control system. A methodology in this project is the design of P, PI, PID controllers using Simulink and MATLAB software, and the step or method to obtain the cruise control system transfer function will be discussed.
Hello doctor, I'm THARSYINI RAMESH. My metric ID is FA17024. So now I would like to talk about the discussion using the data obtained using the simulation in MATLAB. So these are the data obtained from our group using the MATLAB. So through this table, I would like to conclude here where the reduced rise time, increased overshoot, and increased settling time eliminates the steady state error. As the conclusion, we came as the highest overshoot is 35.5634. So I would like to conclude where the proportional integral derivative controller has the highest efficiency compared to other controllers based on the time of rise, time of change, and overshoot. Thank you.
Yes, Assalamualaikum warahmatullahi wabarakatuh. My name is Fatin Munirah binti NASARUDIN. I will explain about the DC motor speed control. In control system, DC motor is a typical actuator which is provide a rotatory motion directly and can provide translations motion along with wheel or drum and cable. And then this is the what I'm using in the MATLAB to evaluate the DC motor controller uh, based on PI, P, and PID. Okay, for this, J will indicate the moment of inertia of the motor. B is motor vehicles friction constants. KE is electromotive force constants. KT motor torque constants. R electric resistance, and L electric inductance. And then this is the example that I'm using in the MATLAB for the P proportional controller. And then if you want to evaluate the PI, then we just adding KI under the KP and just put the value that you want to test. And then for the PID, we add on another unknown, which is KD, to evaluate for the PID. And then for the Simulink model, I will use this Simulink motor model. And then this is a DC motor that for the evaluations, inside the DC motor, this is the subsystem that were created before we add into the analysis model. And then I'm using discrete PID controller, which we can change to the parameter that we want to evaluate, which is P, PI, and PID. This is a P, and then we just put the value that we want to evaluate. This is a PI, have a proportional value and integral value. We can insert the value that we want to evaluate. And lastly is PID, which we have to insert the value for proportional, integral, and derivative to evaluate the PID controller for the DC motor. So that's all from me. We'll continue with the result and discussion.
Assalamualaikum warahmatullahi wabarakatuh. My name is DURRAH ISMAIL. I will proceed to explain the result and the discussion. So this is the value, the parameter of KP, KI and KB for our simulation. So for P, KP is 100, PI controller is 100 and KI is 1. PID controller is 100, 200 and 1 KB. And this is the graph for P controller. Use KP 100. And this is the PI controller. Use KP 100 and KI 1. And this is PID controller. Use KP 100, KI 200 and KB 1. So this is the output of the simulation, which the rise time and settling time also overshoot. The rise time of the P controller is the smallest one, 0.0993. Also, the settling time of P controller is the lowest among the three controllers, which is 0.5669. And the overshoot is 24.9143. So thus, after analyze all the transition response parameters for all controllers, it shows that proportional controller has better performance as it required shortest time from the rise time and the settling time. And lastly, the overshoot value is still make the system stable. So at the conclusion, there are three different controllers: proportional integral, proportional, and proportional integral derivative controller, which have been successfully developed using simulation experiment in MATLAB and Simulink. And this simulation is different in the gain of each controller and the transmission function of the DC motor. In conclusion, in this project, the output is compared with the transition response, which shows the combination of DC motor position and proportional controller have improved the efficiency compared to other controllers based on time of rise, time of change, and overshoot. That's all from me. Thank you.